Hello dear students of class 10th. Very good morning all of you. Now we are going to start fourth part of chapter 2, that is power. Class 10. Power. First of all, there is a question rises in our mind, what is power? Basically, the rate of doing work is called as power. How fast a person do his work is called as his power. For example, if I am running 2 meter in 1 second and some of you might be running that 2 meter in half second, it means that you have more power than me. If I am lifting 10 kg in on my hand in 5 minutes, while you are lifting that 10 kg in 1 second, just in 1 second, it means that you have more power. Whatever be the work done by a source, work done by a person, work done by a machine, whatever be the work done, which is faster than anyone, it means that it has more power. Okay, so the rate of doing work is called as power. So power is, from this statement, power is work done by time taken, work done, that is represented by W, and time taken, that is represented by T. So power is a scalar quantity. It means it has no direction, it has only magnitude. Power is a scalar quantity, it has only magnitude. It has no direction. That's why power is a scalar quantity. As we know that work is equal to F dot S. F dot S, I have explained you, that is a work is a dot product of force and displacement. So work is a F dot S. If we put F dot S in the place of W, work done, it become power is equal to Fs by T. As dot is here, S by T. S by T means displacement upon time. Displacement upon time is said to be velocity, rate of change of displacement. Rate of change of displacement is called as velocity. So power is equal to force dot velocity. Force dot velocity means F dot V. That's why power is also a dot product. That means of two vector quantity, that is force and velocity. That means it is a scalar quantity. Okay. Now come to the point, units of power. Units of power, we can find it by this definition or this formula. Okay, the SI unit of power is what? It is denoted by W. Okay, it is denoted by W. Now we know that power is equal to work done upon time. Work done upon time. The SI unit of work is joule, while time is second. That's why joule upon second, that is work done upon time. Joule upon unit of work is joule and unit of time is second. Work upon joule upon second will become watt. At what is the name of, on the name of James Watt, who has developed many things, and he has contributed power in the discovery of power. That's why it is denoted by watt. Okay, now one watt, it may be there is a question, define 1 watt. When a source or any body, okay, doing 1 joule work in 1 second, 1 joule work in 1 second, then it means that it has a power of 1 watt. Okay, 1 watt is a 1 joule per second. Some bigger units of power are kilowatt, that is 1 kilowatt is equal to 10 to the power 3 watt, megawatt, that is 10 to the power 6 watt, gigawatt 10 to the power 9 watt, milliwatt, that is a smaller unit, milliwatt 10 to the power minus 3 watt, microwatt 10 to the power minus 6 watt. Okay, now come to the point, CGS unit of power. CGS unit of power is Arch per second. Arch as SI unit of force sorry, SI unit of work is CGS unit of work is Arch, and the CGS unit of time is second. That's why it is CGS unit of power is Arch second. There is a relation you have to just remember with you, that 1 watt is equal to 1 joule per second. That has been from here. 1 watt is equal to 1 joule per second. Okay, as we know that 1 joule is equal to 10 to the power 7 arch. 10 to the power 7 arch. Okay, 1 joule is equal to 10 to the power 7 arch. That's why by replacing 1 joule here, 10 to the power 7 arch second inverse means 1 watt is equal to 1 joule per second, that is equal to 10 to the power 7 arch per second. Okay, so this is the units basically you have to be with your mind. Okay, now I am moving to the horsepower. Unit of horsepower. Okay, horsepower is another unit used for measuring power, basically in mechanical energy, basically in machines. Okay, as you go to buy a bike or anything or any machines, that power is denoted by horsepower. Okay, so horsepower is another unit of power. It is a largely used in mechanical energy. Okay, related with the SI unit of power. Horsepower, HP, it is denoted by HP. 1 HP is equal to 746 watt. 746 watt or 0.746 kilowatt. How it comes kilowatt? Okay, just as we know that 1 kilowatt is equal to 10 to the power 3 watt. It means if you want to convert watt into kilowatt, you have to divide it by 1000. And yet, as we know that 1 horsepower is equal to 746 watt. If I want to convert it into kilowatt, just I have to divide 746 upon 1000. Okay, it will become kilowatt. Okay, it means that it will become 0.746 kilowatt. This is the another unit which is used for mechanical energy, or basically used to measure the power of a machine. Okay, now what is difference between work and power? As we know that work is a force into displacement in the direction of, and where the displacement of a body is in the direction of force, while power is a force of work done upon time. Rate of doing work is called as power. So power is a work upon time. Work done does not depends on time, while power depends upon time. SI unit of work is joule, while SI unit of power is watt. There is a basically 3 difference you have to remember. Just go through this and just be clear that you have to know, or you should know how to differentiate power and work. Okay, now come to the point, energy. What is energy? First from question is rises, what is energy? If I hold this pen like this for 1 hour. I feel exhausted after half an hour, after 1 hour. I feel exhausted. It means what happened? Why I am exhausting? Because I am doing work. I am doing work by holding it here. I am doing work by holding it here, and that's why I am expending my energy. My energy. That means that if I have energy, I can do work on some another body. Okay. If I have no energy, I can't do work on some another body. Okay. For doing work, there is a necessity of energy. There should be present. If a body wants to do some job, definitely that body should have energy. Okay, definitely that body should have energy, then he may or she may able to do some job. Okay, means that what is energy? Energy is the capacity of doing work. Basically, for example, if I am doing work by holding this marker from here to here, just I am losing energy. Where it goes? It will goes to the work done on this body, and it will becomes its energy. Means when I will work, I will lose energy, and the body on which work is done, it will gain energy. Definitely. That's why energy is called as capacity of doing work. Okay, the energy of a body is its capacity to do work. Now, units of energy. The SI unit of energy is joule. As we know that the SI unit of energy is joule, as because energy and work is related with each other. If I am doing work on somebody, definitely the energy of that body will get rise. Means I am transferring the work from one body to another body. That's why the SI unit of work and energy is same, that is joule. That's why CGS unit of energy is urge, as CGS unit of work is urge. As we have already studied that 1 joule is equal to 10 to power 7 urge. The bigger units of energy are watt hour, kilowatt hour. Okay, so first of all, understand what is watt hour. Watt hour is the unit of energy. So first of all, understand what is watt hour. Watt hour or kilowatt hour. Watt hour and kilowatt hour. Okay, so unit of energy is joule. SI unit of energy is joule, or some other energy like kilowatt. Just understand kilowatt or watt hour. Okay, watt hour, kilowatt hour or watt hour. Okay, watt hour, 1 watt hour or kilowatt hour. Just understand this two bigger units of energy. How we will understand this? Come to the point. Come to the point. Okay, now watt hour. First of all, understand what is watt. We know that power is equal to work upon time. Means power is watt. Okay, and work means joule. Okay, I'm just writing J. and time means second. Okay, if I multiply watt second, it will give you watt second, it will give you joule, it will give you joule. If I multiply watt second, it will give you joule. Now come to the point. Here is a watt hour. What means joule per second? Joule per second. Okay. Hour means time. 1 hour means 3600 second. Joule second into 3600 second. As we know that 1 hour contains 60 minutes and 60 minutes 1 minute contains 60 seconds. That's multiplying, we get 3600 seconds. Second and second will be cancelled out, and that will be equal to 3600 joule. Okay, so 1 watt hour is equal to 3600 joule. 1 watt hour is equal to 3600 joule. You have to be with your mind. Okay, now 1 kilowatt hour. Come to the point. 1 kilowatt hour. 1 kilowatt hour. Now 1 kilo means 10 to the power 1000. 1 kilo means 1000. 1000. 1 kilo means 1000. Okay. Watt, as we know that watt is equal to joule per second. Joule per second. Okay. Watt means joule per second. Okay. Into now hour. Hour means 3600. As we know that 1 hour is equal to 60 minute into 60 second. That is 3600 second. Okay, 3600 second. That is 3600 second. Okay, in which second will be cancelled out. Now it will become 36 into 10 to the power 5 joule. If we multiply 36 into 10 divided by 10, and just multiplying and dividing with the same digit, okay, that is 10, okay, into 10 to the power 5 joule. It means it will become 3.6 into 10 to the power 6 joule. Means 1 watt hour is equal to 1 watt hour is equal to 3.6 into 10 to the power 6 joule. Or you may also write it 1 watt hour is equal to 3.6 megajoule. Okay, 3.6 megajoule. As we know that 1 mega is equal to 10 to the power 6. 1 megajoule is equal to 10 to the power 6 joule. That's why we can write that mega 3.6 mega joule. Some another units of energy are calorie. Calorie is basically used for measuring heat energy. What is 1 calorie? Basically, the energy required to 1 kg or 1 gram of any substance to raise its temperature from 14 degrees Celsius to 15 degrees Celsius. You might maybe write as 14.5 degrees Celsius to 15.5 degrees Celsius by rising 1 degree Celsius. Okay, the energy required to any substance of 1 gram to increase by its temperature 1 degree Celsius, that energy is called as 1 calorie. Okay, there is a relation between calorie and joule. Just go through it. 1 joule is equal to 0.24 calorie, means 1 calorie is equal to 4.18 joule. You have to be with your mind that 1 calorie is equal to 4.18 joule. Okay, kilocalorie is the bigger unit, that means you will multiply 1000 by it. Just I'm clearing it. Okay, just you have to remember that what is calorie. Calorie is the unit of energy. Basically it is used to measure heat energy. Okay, so 1 calorie is the amount of heat energy required to a substance of 1 gram by increasing its temperature 1 degree Celsius. That is called as 1 calorie. Okay, so 1 joule is equal to 0.24 calorie. Okay, calorie. Okay, or you may also write as 1 calorie is equal to 4.18 joule. 4.18 joule. Okay, now you may also write as 1 kilocalorie. 1 kilo means you have to multiply it with 1000. Calorie you may also write it as calorie. Okay, in short. So you will multiply this by 1000 into 4.18 joule. After removing it, you will get 4180 joule, means 4180 joule is equal to 1 kilocalorie. One another unit is electron volt. The energy transferred in a case of atomic particles is very small, so it is measured in electron volt. Okay, 1 electron volt is the energy gained by an electron when it is accelerated through the potential difference of 1 volt. In higher class you will come to know that in energy, just voltage is equal to voltage potential difference. Voltage is equal to, that is potential difference is equal to work upon charge. Okay, work upon charge. Work means joule, charge work will be potential into charge. Potential into charge. Okay, so here unit of work is joule, unit of potential work done joule per coulomb, and here is coulomb. Coulomb will be cancelled and it will become now I am multiplying that volt. 1 volt is the unit of potential, so volt into coulomb. Volt coulomb will become joule. Volt coulomb will become joule. So it is 1 electron volt is the energy gained by an electron when it is accelerated through a potential difference of 1 volt. So 1 electron volt is equal to, now come to the point, 1 electron volt is equal to just you have to learn this and remember it, its value related with 1 electron volt is equal to charge on an electron, charge on an electron into potential, means 1 volt. Okay, charge on 1 electron, we know that charge on 1 electron is 1.6 into 10 to the power minus 19 coulomb. Okay, minus 19 coulomb into 1 volt, into 1 volt. Okay, that's why it will become, volt into coulomb will become joule. So 1.6 into 10 to the power minus 19 volt into coulomb will become joule. So 1 electron volt will be equal to 1.6 into 10 to the power minus 19 joule. It is a very smaller unit, as we know that 10 to the power minus 19 is a very smaller thing. That's why it is very smaller. So right now come to the point, what is difference between energy and power? Energy of a body is its capacity to do work. Whatever my capacity to do work, it means that it is my energy. Okay, power of a source is the rate of at which energy is supplied by it. Means from what rate, from what capacity I'm just supplying that energy. I have lots of energy, but my rate is very slow. It means that I have low power. Okay, now the energy is spent does not depends on time. But basically, if you simplicity, or you will expend your energy, or if you work faster, it does not depends on time. Power depends on the time. While SI unit of energy is joule, while SI unit of power is watt. So learn this, read this, and whatever you face problem, just ask me on Google Classroom or by any means. Okay dear, have a nice day. In next class I will be discuss the numerical problem, and I will send you the PDF of numerical whole. Okay, bye all of you.